Welcome to the School of Life. Life is hard, but you have got to be harder. I'm Mrs. Collins, your life coach. Let's get started with Unit 2, Lesson 8, Diagonals of Quadrilaterals. Our essential questions for this lesson are, what are the properties of a quadrilateral? And how can I classify a quadrilateral on the coordinate plane? We'll start off by answering the question, what are diagonals? So diagonals are, or a diagonal is, a segment connecting opposite corners of a quadrilateral. As a visual, here's a quadrilateral, four-sided shape. And inside, I'll connect this corner with this corner. These are opposite corners. This would be classified as a diagonal. So that's our example. So if the following statements are true, then a quadrilateral or the quadrilateral might be a something. So if the diagonals are perpendicular, then this particular quadrilateral that we'll be referencing might be a square, a rhombus, or a kite. So if we end up calculating and we find that our diagonals are perpendicular, then that shape might be a square, a rhombus, or a kite. Remember that if it is perpendicular, then that means that the slopes are opposite reciprocals. Okay, and one thing that you should think, so if you have a fraction that's a over b, then it will turn into a negative b over a. If it is true that the diagonals are congruent, then this might be a square or a rectangle. Remember that another word for congruent is equal. So if you calculate the distance of or the lengths of the two diagonals and they come out to be equal, then that shape might be either a square or a rectangle. So if a question asks you to describe the diagonals, it wants to know if they are congruent, perpendicular, or both. So are they equal, are they perpendicular, or are they both congruent and perpendicular? Again, remembering that congruent, another word for it is equal. And if we're trying to see if something is equal, we'll be using the distance formula. If we're endeavoring to see if something is perpendicular, we'll be finding the slope. Okay, so again, to check to see if they are perpendicular, use the slope formula. And then again, to check to see if they are congruent, use the distance formula. So we have example number 1, quadrilateral QRST with vertices that are given to us is a rhombus. Verify that it is a rhombus by showing that it has perpendicular diagonals. So perpendicular diagonals. In these problems, one thing that you'll want to do first is sketch it out. After you've sketched it out, they're telling you exactly what they want you to figure out. See if it has perpendicular diagonals. Since it's asking us about the perpendicular diagonals, we're going to need to calculate the slope for each of the diagonals. So here we have our sketch of QRST. And the next thing that we're going to do is look at the two diagonals. So T to R is our first diagonal, and then our second diagonal would be our Q to S. So two diagonals. So I'm going to write that, diagonals. We have QRQS is one diagonal, and then our other was TR. Okay, Again, perpendicular diagonals. We're looking to show that they have perpendicular diagonals. So therefore, we're going to need to calculate their slopes. So we have the slopes of QS and RT. So for QS, we have M equals 6 minus 3 over negative 2 minus 1. 6 minus 3 gives us 3. And negative 2 minus 1 gives us a negative 3. So our slope is 3 over negative 3, which is the same thing as negative 1. For the next one, we have our 2 points for T and R. M equals 2 minus 7 over negative 3 minus 2. 2 minus 7 gives us a negative 5 over a negative 3 minus 2 is also a negative 5. Negative 5 divided by negative 5 gives a positive 1. So in comparing our two slopes, we need to once again see if they are perpendicular. So we're looking to see, are they opposite reciprocals? Well, a negative 1 is the same thing as a negative 1 over 1. A 1 is the same thing as 1 over 1. One fraction is negative while the other is positive, so that gives us the opposite. And then they are also reciprocals. 1 over 1, flip it, it becomes 1 over 1. So therefore, these two are perpendicular. So therefore, we have verified that this is a rhombus by showing that it has perpendicular diagonals. So that's all we need to do. Just simply show your work and show that these have the opposite reciprocal slopes. We're done with number 1. For number 2, we have quadrilateral MNOP with vertices that are given to us is a rectangle. And it says verify that this is a rectangle by showing it has congruent diagonals. So once again, we're looking for congruent diagonals. So the word congruent, think about distance. And the diagonals, we will come up with that shortly. But they are MO and NP. So sides MO and NP. Let's sketch it out just to verify that those are our actual diagonals. All right, with our sketch, we can definitely see that MO is one of our diagonals and NP is the other. So once again, we're going to verify that this is a rectangle by showing that it has congruent diagonals. So we have our two diagonals, and they are again MO and NP. And then we're going to calculate the distance for each of them. So for MO, we have that the distance is equal to the square root of 8 minus 2 squared plus 6 minus 4 squared, which gives us the square root of 6 squared plus 6 minus 4 is 2 squared, which will give us the square root of 36 plus 4, which is equal to the square root of 40. If you break down the square root of 40, let's say over here on the side, we have 10 times 4. For 10, we have 5 and 2. 4, we have 2 times 2. Here are our pair of 2's, so our answer will be a 2 on the outside. And then inside, we have that 5 and the 2 with no pairs, so we multiply them back together, and it gives us a 10. So 2 times the square root of 10. So the square root of 40 is also equal to 2 times the square root of 10 when it's simplified. Okay, so next we have the distance for NP. So that's D equals the square root. We have our 6 minus 4 squared plus 8 minus 2 squared, which gives us 2 squared plus 6 squared, which is equal to the square root of 4 plus 36, which equals the square root of 40, which also breaks down to 2 times the square root of 10. So as you can notice, the distance for MO is 2 times the square root of 10, and the distance for NP is 2 times the square root of 10. They are equal. So the only thing we were looking to do is just show that they're equal. Verify. Show that this rectangle, or that this is a rectangle because they have congruent diagonals. Congruent means that their two distances are exactly the same. And so we have completed the problem. For numbers 3 and 4, you try each of these. Remember that we're simply verifying whether it's a square, or for number 4, whether it's a rhombus. And we are doing exactly what they're asking us to do. So for number 3, we're verifying that this is a square by showing that it has perpendicular and congruent diagonals. So perpendicular, remember that you must look at its slopes and identify that they're opposite reciprocals. And then for congruent, look at its distances and then verify that those two distances are exactly the same. For number 4, verify that it's a rhombus by showing that it has perpendicular diagonals. So again, perpendicular means that you're looking at its slopes and you're verifying that they are opposite reciprocals. So please pause your video and try numbers 3 and 4. All right, so for number 3, once again, perpendicular means that you needed to identify the slopes of both of your diagonals, BD and CA. The slope for BD was -1/5, and for CA it was 5/1. These are opposite reciprocals of each other, so therefore it has been verified. Check. Distances. When using the distance formula, we're looking to see if they're congruent. So therefore BD was the square root of 104. CA was the square root of 104. They are the same, so they are congruent. So check. We are done with number 3. For number 4. For number 4, we have our sketch. We were looking to verify that this is a rhombus by showing it has perpendicular diagonals. So we were looking at the slopes. For BD, we had a slope of a -1. And for CA, we have a slope of 1. For perpendicular, they have to be opposite reciprocals. So we look at this one as a as a fraction. It's -1/1. And your second one is 1/1. These are opposite reciprocals. The top fraction is -1/1, and the bottom fraction is a positive 1/1. These are opposite reciprocals. Therefore, we have verified that the diagonals are perpendicular, and we are done.